Hi everyone, I'm Lizzie and I'm going to be talking about my battery Jenga work. And thank you, Chris, for inviting me as well to just talk about resource development publication. And I know, as we just said, trying to put the spotlight on it. So before I start, I'll introduce myself properly, because one thing that I've got from doing outreach is people don't think I'm a scientist, and I have to be like, no, I am. So who am I? So I've been at Birmingham for quite some time, minus 1 year down Oxford. I am a solid state chemist, used to be doing energy generation with solar perovskites before doing a PhD in novel electromaterials and educational resources for lithium and sodium ion batteries. So got a chapter in there. So looking into sodium ion, high power lithium ion anodes, and also about battery education engagement. And now I met Matt as a research fellow with Emma Kendrick on the RELIVE project, looking into recycling lithium ion batteries. So sort of the fundamentals before I go into the resource. We go back to basics and just appreciate the science before we actually look into how we can explain it. I am sorry if this is teaching you guys to suck eggs if you already know how a battery works. But essentially, a battery has 2 electrodes and electrolyte, and that's the same across the board if it's primary or secondary battery, so non-rechargeable, rechargeable. But what we do have here is we have the cathode, classic sort of lithium cobalt oxide positive and aluminium foil. We've got the anode, which is graphite on copper foil, and you'd have an electrolyte in between, so just a liquid just to help the lithium shuffle. So where the magic happens, you obviously have a redox on your cathodes, but also you have the electron shuttling in the external circuit. Battery chemists, just to note, they label it on the electrodes on discharge, so that also causes confusion what a cathode and anode is. So coming on to, hopefully that's okay with that sort of just general intro. But coming on to what I actually did, it's battery Jenga. So let's ignore the electrolyte. We don't care about that. It helps shuffle the lithiums from the electrodes from the anode to the cathode. But what we actually developed is battery Jenga. So we make use of what the structure types look like. So lithium cobalt oxide is a layered structure. Graphite is also layered. So the first demo we can do is just talk about charging and discharging. So normally with the kids in the classroom, you just say like, well, what do you do when your tablet dies, when you're messing on TikTok? Because that's what the kids use now. I think that's aging me a bit. And they say, well, when it's dead, I plug it in. And I'm like, this is where we can start thinking about what's going on inside the battery. It's dead, we plug it in. And with the charging, we're getting the lithium, which is the blue blocks, getting shuttled across into the graphite. And the reverse happens on discharge. We can also think about rate of charge. Everyone wants a battery to like be charged just at a click of your hands. But really, if we look at the crystal structure sort of point of view, we can do a slow charge. The structure's okay on the left-hand side, but on the right-hand side, in a moment, you'll see we get structure collapse. So this is probably one of my favorite demonstrations to do, because the kids, they try and just like do it fast, but they don't want to take everything out. But this actually relates to what actually happens with the chemistry of the system. If you pull out all the lithium of lithium cobalt oxide, you get structure collapse, and you're going to have a bad time because you're going to be releasing oxygen and you've got a flammable electrolyte. We can also think about degradation as well. And so this comes on to, everyone's always like, my battery like dies after 2 years. Why? And well, we can just look at it at Jenga. If we keep cycling, which is charging and discharging, we can see how the towers, get a bit wonky. After all, it is a crystal structure. I think that's the amazing thing about materials, how you can make something really tiny with powders and actually make a functioning device. And a lot of these sort of demos here actually relates to questions that we got from doing outreach. So rather than people want to know like what you do in the lab, they want to know like, make it relatable to what they do with their devices. Like, why is it dying? I always get asked like, what's the best way to charge it? Like, do you charge it really fast because the 80% and then the final 20% and stuff like that? So with outreach, it's not so much as jumping straight in, you're going to be leading everything. For me, it was a gradual sort of build, and hopefully in the coming weeks when you see Jamie Gallagher's, he has a mountain where you just sort of gradually climb up to be able to deliver outreach yourself. So about this then, we'll talk about the publication in a moment. So where did it actually start? So this was started nearly 4 years ago, which is crazy. And I think COVID's really messed with my sort of timeline because of those 2 years. And it actually started as a painted set. So I spent about 20 hours of my own time in the evening painting it to look like those crystal structures. And this is like when I delivered it to a year 8 class. So one thing as well, when it comes to your resource, it's never going to be perfect straight away. There's always things to learn. And I suppose that applies for science. And I know Chris is aiming to get you guys to like apply for funding. So I was rehashing some of my old slides yesterday, and I was looking at the grant application. So when we had that Jenga set from 4 years ago, we applied for some funding, only 180 quid, just to start off. And this was for the Green Heart Festival at the University of Birmingham. So my top tip when it comes to these forms, copy and paste the questions, and then you can work on it gradually. And it's basically telling them what you want to do and making sure that you're really clear on what your idea is, because if they don't get it, they're not going to fund it. Know your audience, that's another thing. So it's kind of asking like those questions, I suppose, like the 5 whys and how. What are you going to do with the money? Can you budget it? I know sometimes when it comes to grants, it's normally like oh, we're going to spend this much there. Sometimes it just doesn't go to plan. But probably the hardest one to do is they'll ask you about the legacy and impact. And that comes down to feedback. And that's probably the hardest thing to do when it comes to outreach, just to justify why you're doing it. Are you having that impact? Was the money worthwhile? So this was the outcome as well. With that 180 quid, we made a massive Jenga set, which is really heavy, and it's only probably come out a few times. It's currently in chemistry still, and this was with Coco Mad with Chris, which is scary. It's over 3 years ago, which I think is insane. So this set gets wheeled out every so often, and again, rather than painting it this time, we were like, okay, let's use stickers instead. But coming back onto the grant application, like, because I think I was rather going to speak about it in person than have a slide on it. It's the ups and downs, and I won't name them in particular, but when I tried to get funding, I thought, it's very similar to what I wrote previously. I thought it was sound. And then I sent it to someone, and the thing is, they just weren't interested. And rather than saying good, bad, good, I got an awful email. And this was in 2019, mid-PhD. I cried. It was that bad of an email. And I was just like, what's the point of me doing this? And it's kind of, I had my supervisor at the time, he was like, well, find the money somewhere else. And we did. And we just kept going. And with those people before, I've tried something recently with them, and I think it's just them. So you kind of get a feel for it. I might tell you later, Chris. And funny enough, they came back to me over the year saying, can you give us some sort of feedback and like for us to get this award? And I'm just thinking, I haven't had the best experience with you guys. I'm not sure if I'll be the best person for that. So there will be ups and downs with it. So Inspirational Training, are you in this? No, John's in this photo. John Wood's in this photo. So this again is a few years back, and developing on with Bachelor Jenga. Ruth Patchett, she was an outreach officer in chemistry. Sadly, COVID meant her contract got. But it was really useful to have that sort of, that appreciation for sort of visual impairment. To basically, if you can make your resource accessible to everyone, then it sounds. Whereas before with the painted, it has no textures and stuff like that. So we're kind of limiting ourselves there. So developing on with that, with the accessibility, we had a master's student at the time, Emily Hayward. She's now, I think, 3rd year PhD with Pete. And some of her research was looking into making sort of solid state chemistry, things to do with the defects. How do you make those accessible? And some of the main findings is like, it's on the NHS website. So if you're colorblind, which I think is the main visual impairment, go for blues and greens, not blues and greens, blues and yellows. Greens and red are the no-nos. So we developed it a bit further. So we've got this other Jenga set here. It's absolutely mad how many sets we ended up. And these are the textures. And one thing I'm really keen on when it comes to these resources, I suppose it comes down to, like, my PhD had no funding. So it's kind of making the most of what you had and just finding bits of craft pieces that I can use. So the graphite, how it's a layered structure, I just peeled the top layer off of the cardboard so you get that ridge texture, and just painted it up. And we worked with some teachers who gave us some feedback, and we developed the activity further. So with the slow and fast charge, they said, well, why don't you add a bit of audio to it? So when the kids do it now, I'm the beep. So I get, when I beep, they have to pull the lithium out, and I have a lot of fun with the fast one. It's kind of thing is, when they're too gentle with it, I just push it over anyway. So as well, this is probably the hardest thing when it comes to outreach. It's the feedback. So one thing I did for the publication was really, it was assessing what the students thought and if they felt like they understood it. So I suppose from another education point of view, there'll probably be, you'd want to maybe assess it, but then this is outreach. So I kind of got them to think about, well, what's, you know, what do you associate with, you know, lithium ions? What do you associate rechargeable? And that was before. And then I did an after survey, and it's really interesting. You see how you have more like sort of general applications to begin with, and then you end up getting more science after you've done the demo. And then as well, just asking them, you know, do they feel like afterwards they can explain how these batteries work? So I had this sort of set of questionnaire really. And one thing that I learned as well, when it has the little boxes of not all too greatly, that's called a Likert scale, if you ever need to find some templates on Google for that. But there's many ways of getting feedback, so it's down to your event on what you think the best thing is. It could just be like 3 beakers of like happy face, neutral face. Always have a neutral face. Jamie Gallagher would tell you to have a neutral face or a sad face, and then you can just get them to put tokens in of what they think. So it depends on your activity, how much time you've got to do with them, and just sort of what do you want to get out of it, I suppose. But that's probably the hardest bit to do. One thing that I really am trying to push with is just teamwork is key for this, because it does take a lot of time, but if you've got others to join in with you, it helps so much. And again, this is another pre-COVID. I promise I will start presenting stuff that is more recent, but I was going back over some slides of when I spoke about the highs and lows of this. So it's publication. If you haven't published before, it's probably like more relevant to sort of PhDs who've just started. You will you find a sort of relevant journal, you get it in their sort of setup of what they want the paper to look like, send it off. If it gets past the initial check, they'll then send it out to reviewers. So originally I tried the RSC, might be chemical education or something like that, but they're more interested in the sort of theory and learning and frameworks and stuff like that. So this activity wasn't really relevant to them. And to be honest, they got rejection straight away, which is fine. Obviously didn't take it personally. I understood that it wasn't the right journal. So then we tried for the American Chemical Society, and amazingly, this went to 5 reviewers. So normally when my science papers, I've had tops 3. So this was like, whoa, having to respond to all of them. So that was, yeah, that was quite nice. That accepted with, you know, minor revisions and stuff like that. And we did that. So I suppose with this slide anyway, if you want to publish it, make sure you have feedback. Have a look at what other people have done in these sort of journals to get appreciation of what you want to do to then publish. But don't be put off if you get a desk rejection. That happens. And it shouldn't be. I don't want to say that's the norm in academia, but it is. And yeah. So raising awareness. So papers accepted. Now what? So you'd have a bit of a time before it actually goes live. So with the ACS, they had the editors in there. One teacher asked me, why did you go for the American one instead of the RSC journal? I was like, well, they didn't want it to begin with. I had to go to ACS, which is fine. And I think also it's interesting, I got told like about the spelling of the colours in the American with the grey rather than the UK. Yeah. So how did I actually publicize what we were doing? Well, first off, you have a media team at the university. This doesn't necessarily have to just apply to outreach publications, it applies to science. You go to them and say like, well, the embargo it finishes on this date, let's try and get the publication and like the sort of news stories with that, and they'll have partners. So I went to the university. Probably they'll have different sort of teams for the different colleges, I can't remember really. And you kind of get the notes together and then the link, but they'll also have news partners. Other things that I've done as well is with Twitter. I kind of see like I'm sort of lazy when it comes to sort of visuals, and on Twitter, I want to know all the information straight away rather than reading. So I made a little GIF just to sort of outline that these are the things that shows in this paper. It's just a shame what's happening to Twitter at the moment. So with the reach then, so how did we do? So these sort of several news in the middle, those are associated with what the university, their sort of partners had. We got it picked up with the RSC, had a contact there, and they also published on it too. And then it sort of became a chain reaction. So we had the American Ceramic Society, rather than just taking the sort of news story, they actually made like a nice little title for it, unblocking your learning potential. Had it appeared in the National Geographic, because they're like, oh, if you want to learn about how the batteries work, look at this. We had Discover magazine reach out saying, hey, we've seen your paper, can we talk a bit more about it? And I was like, yeah. And then again, Naked Scientists, so it kind of got out that we've got a resource that explains these type of batteries, and these batteries are everywhere. There's one here, one there, but literally if you look in the sort of education journals, people they're talking about how to make lithium-ion batteries with the coin cells. So those are like sort of watch button batteries that you can get, but to have the equipment for that's schools are not going to have that. So, and the thing is, no one's really talking about it. One thing that they do talk about is the lemon cells. They're accessible, they're tactile, but the thing is they're non-rechargeable cells, really. They're not rechargeable. So this is how we sort of branched into this sort of little niche that, hey, we're going to explain how lithium-ion batteries work. So really proud of this piece. And I always kind of felt, this is personal reflection, that I'm a Mickey Mouse scientist because I'm publishing on this, and then people just think that this is what I've been doing for the past couple of years, but it's taken off phenomenal. And then you can have a look at the alt metric. So because I got it on Twitter as well, that pushes up the alt metric. So maybe if Twitter goes down, my alt metric's going to go low, but it gives you a representation of, like, for the age of the piece, how well did it do? And it's still standing at #1 for the age of it, but it's going down on other things. And final thing on this slide with the map as well, it will tell you where it's been reached. And we've reached quite far with it, which is amazing. And one thing this has gone down since I last updated it, since I last did it about a year ago. But yesterday, about 45% are members of the public. So we're really hitting not just scientists, we're getting this message out of like how these batteries work, which is going to be, with the move for electric vehicles, actually understand what science is doing, what funding's going to, and what you're buying into. And one thing that was quite cool as well, so this is one person, I can't remember if they followed me before, it might have been after Battery Jenga, but this is in Oklahoma. They've done their own set, which is amazing to see that they've given it a go and they've had success with it too. So other side things I'm going to talk about now are sort of other madness things that I've done in the past couple of years as well. Chris is actually there as a cobalt home. So as well as Battery Jenga, we did the human lithium-ion battery. Same sort of setup, but this time we've got the electrolyte in the middle. Let they all come back on again. The electrolyte in the middle, and then we've got the electrons with the beach ball. So you see that's charging, and then on discharge, you'll see the light bulb change around. So again, just another representation of how we can show this, how these batteries work. Other sort of things that's happened in the group. So had a few interns over the past years with Emma and Pete, and a lot of things when it comes to batteries, you can relate back to cake. So again, with the different electrodes, kind of baking a cake. And these are Emma's here, where she had the sort of stages of baking, which is similar to when we make our electrodes, you dry it and calendar it, and then you have the assembly. And then another student thinking about sort of icing electrodes, rather than just having the sort of fundamentals, how batteries work. Let's talk about how we make them. And those are like electrode inks that we then paste onto foil. But we can do that with icing sugar, corn flour. It just gives kids a chance to have a go at making what it's like to make an electrode, and how in some cases, if you go a bit too runny, it's going to be rubbish. So current and future work, I'm still working on the splash. It's kind of, it's in my own time at the moment, educational resource, which is funded from the RSC. I did say at the beginning, my first sort of grant was 180 quid. This one we got to 10k, which is quite nice, just seeing just how you develop, and as well doing behind the lab spec. So I'm quite keen, I suppose this can play in for discovered materials as well, that from a personal perspective, I ended up in chemistry by accident. I wanted to do physics because I liked materials at A level, got rejected, got put into electrical engineering. I was like, nah, no thanks, I hated electricity at A level, and then got moved into chemistry. And I think one of the key things here is materials is not really spoken enough about. And then relating it back to sort of careers is you don't necessarily have to wear a lab coat to be in the battery industry, which is what's taking off right now. So interviewing quite a few different people here and there, academia, industry and students. I still need to finish getting some of these videos out. But where has this also led to us? So this is lovely Ali, who we still work with. And again, found lemon battery notice in the Eden project. But this is just to say just how engagement can actually link back into your own research. So these guys are Cornish Lithium, and they're looking into a lithium source in Cornwall, as the name says, but through geothermal waters. So rather than traditional hard rock or underground reservoirs, such as in South America. So it's really neat how they've just got this borehole. They're getting the lithium out because they're looking at old mine maps as well from like 18th century where they were mining for tin, and they noticed lithium, but obviously at the time it just wasn't useful. So really interesting. So yeah, I said to them, hey, can I have your waters? And I think they got a bit confused because they're like, don't you just do outreach? And I'm like, no, I want your waters too. So it can beneficially like play back into your own work too. So my words of motivation, it doesn't have to be a massive gesture when it comes to outreach. You can get involved with what, say, Chris is doing, which is fantastic. And just having that role, and then you get more comfortable, more confident, that actually you might want to try something a little bit different. And, you know, it comes in many different forms. But make sure, I think this is probably really hard when obviously I'm grateful for you guys turning up, but when I say about most importantly, do it because you want to do it. And it's really hard to try and get people to do outreach because it's just they probably don't see the merit in maybe. Further incentive, I did actually go to, it was a conference last year when they were talking about engagement work, and this one student was talking about how she was using memes to communicate. So even just a simple thing on social media, that's engaging. But yeah, I mean, if people could start citing my other science work, I mean, that'd be great. But yeah, battery Jenga is it's got 5 citations, which is mad. And let's see if this will work actually. So this is back to baking a battery as well. We made a shredder, so that's what we currently do. I currently do with recycling. So the noise is ridiculous when it's made, but yeah, made a gingerbread shredder. So it's not a one-man band, lots of people involved. We've got Pete, Emma, Pooja, Ruth, some of the teachers, Helen, Josh, Floor 5, Energy Materials, and just the funding in that. So there's loads of different people involved, and I always feel when I'm here, it's just like it's not just me. There's many other people. So yeah, stop that. And thank you for your attention. I hope that was okay.